Welcome to This Explainer. Today, we're jumping right into one of the most mind-bending mysteries of our existence, cosmic fine-tuning. We're going to look at how the fundamental physical constants of our universe seem perfectly, almost unbelievably, calibrated to actually allow life to exist. Let's get into it.
I want you to imagine a massive cosmic control panel. Picture it covered in countless little dials, with each one representing a fundamental physical force or the mass of a particle. So, what would happen to us, to biology, planets, the whole shebang, if we were to barely nudge even just one of those dials? Like, by just 1%.
While to really understand this control panel, we first need to talk about fine-tuning. Basically, this is the idea that our universe functions, and specifically its ability to harbor life functions, only because its underlying parameters fall within a remarkably precise, super narrow range of values. If these numbers were even a tiny bit different, the biological building blocks required for your existence, they just couldn't exist.
To kind of help visualize this, the physicist George Gamow wrote these famous Mr. Tompkins stories. He imagined a wonderland where these physical dials are actually tweaked. For example, if you drastically slowed down the speed of light, a simple everyday bicycle ride turns into this visually distorted trick where you literally see the effects of relativity with the naked eye. It's a great reminder that our normal daily reality is entirely dictated by these hidden numbers.
Section 1. The macro dials. We'll look at gravity and cosmic expansion. Okay, let's see how these macro dials build the massive structures of our universe. Now, gravity obviously feels incredibly strong when we fall, but on a cosmic scale, it's actually a super fragile balance. If you turn the gravity dial down just a little bit, the pull becomes too weak, meaning life-giving galaxies and planets just never form in the first place. But if you turn it up, stars form from way too little material. They become tiny and burn out almost instantly, which leaves absolutely no time for complex life to evolve.
And then we've got the cosmological constant. This represents the vacuum energy of space, and man, this dial is wildly precise. Theoretical physics suggests it should naturally be vastly larger than it actually is. If we give this dial even the slightest turn, the universe either expands so rapidly that matter can never condense into stars, or it just immediately collapses back in on itself in a big crunch. Either way, the universe becomes a dead, sterile wasteland.
Moving on to Section 2, the microdials, and the recipe for matter.
So it's not just the giant stuff out in deep space. We have to zoom way, way down to microscopic building blocks, like quarks, to see how solid matter exists at all. These particles are absurdly light. To put that into perspective, an electron is to an apple what a grain of sand is to Mount Everest. The down quark has a mass of 8.6 times 10 to the negative 27th power grams. If that dial gets turned up just a hair to 2.6 times 10 to the negative 26th power, adios periodic table, we would lose all chemical complexity, making biology completely impossible. We'd literally be left with a single, lifeless chemical element.
Which brings us to another hyper-precise microdial, 0.7%. That number is the exact magical mass-to-energy conversion rate when 4 protons fuse into helium. It's a process that happens inside stars right now, and it happened just after the Big Bang. So why does that 0.7% matter so much to us? Well, if you tweak that conversion dial down to 0.6%, protons wouldn't bind together, and our entire universe would only contain hydrogen. But if you bump it to 0.8%, fusion happens so easily that all the hydrogen would have been destroyed early on. And think about it, without hydrogen, there is no water. And no water means absolutely no biology, period.
Then there's the strong nuclear force, which just perfectly balances the electromagnetic force. The late astrophysicist Fred Hoyle realized that this specific balance hits what he called a resonance. It's this exact resonance that allows dying stars to forge the precise amounts of carbon and oxygen we need. If the strong force was even slightly different, stars might make carbon or they might make oxygen, but they wouldn't make both. And for you and me to be here having this conversation, we absolutely need both.
Section 3, the entropy dial and the low entropy mystery.
To measure just how incredibly unique our universe's starting conditions were, physicists use a concept called phase space. Now, phase space isn't a physical place, it's more of an abstract mathematical way to represent every single possible arrangement of particles, so their exact locations and velocities, at the exact moment of the universe's birth. It's like a giant cosmic puzzle of all possible realities.
The renowned physicist Roger Penrose actually calculated the odds of our universe beginning in its necessary, highly ordered, low-entropy state just by random chance, and he arrived at this staggeringly incomprehensible number,
1 in 10 to the power of 10 to the power of 123. Let that sink in. If you tried to write this number out, you would literally run out of atoms in the observable universe before you finished writing the zeros.
The contrast here is just catastrophic. Penrose pictured a creator dropping a pin into that vast phase space. Because it hit the exact right, highly improbable spot, we got atoms, stars, and ultimately, life. If that pin dropped almost anywhere else, we wouldn't have a complex universe at all. We just have this featureless, dead sea of high-entropy black holes.
Section 4. Explaining the impossible odds. So, we are kind of left with a cosmic cold case. We're looking at a universe so impossibly fine-tuned for life that impartial scientific and philosophical analysis basically leaves us with 3 primary explanations for our control panel's settings. Those are chance, necessity, and design. Let's break each of these down.
First up, the chance argument, which is most commonly expressed today as the multiverse hypothesis. This idea suggests that our universe is just one of infinite parallel realities. So in this vast multiverse, the cosmic dials are just randomly shuffled in every single universe. Most of them are dead. But if you have infinite rolls of the dice, a life-permitting universe like ours becomes an inevitable statistical outcome. We just happen to live in the one capable of supporting observers.
Next, we have the necessity argument. This really relies on the hope that deeper, future physics will eventually discover a theory of everything. Think of Albert Einstein's ultimate dream, finding an elegant mathematical equation that proves these dials were basically locked in place by fundamental principles. In this view, the universe simply had to be this way, and the constants never actually had a choice to be anything else.
And finally, there's the teleological, or design, argument. This viewpoint takes these incredibly precise numbers, like Penrose's entropy calculation or Hoyle's carbon resonance, as evidence that the cosmic dials were purposefully calibrated. It argues that an intelligent creator deliberately selected those exact initial conditions, specifically to bring about complex structures and, well, us.
Ultimately, whether you think these constants point to a vast multiverse, an undiscovered equation, or a purposeful creator, they remain exactly what the brilliant physicist Richard Feynman declared them to be. When talking about the fine structure constant, he called it one of the greatest damn mysteries of physics, a magic number that comes to us with no understanding by man.
Which leaves us with the ultimate question as we wrap up this explainer. When you look at the impossible exactness required for water, for carbon, and for biology itself, which answer makes the most sense to you? Are we a lucky cosmic jackpot, a mathematical necessity, or purposefully designed? It is a mystery well worth pondering. Thanks so much for exploring the cosmic control panel with me.